let's get started, man. Let's get started. All right, guys. Cool. So we're going to talk about visual agents. Um, so what I hope to accomplish today, or rather like kind of the flow, the journey I want to take you on over the next, I think 90 minutes or so. I'm going to help you understand what it is that I mean when I talk about a GUI agent. And the point I want to drive home today, it's all about the data. Data is everything. I want to talk about, you know, inconsistencies with formats and annotations, some tips for scaling data curation. I'll set you up for what you need to do to train a specialized model. We'll talk a little bit about evaluation in FiftyOne, but the focus really is on data and on data curation. Uh, I'm Harpreet Sahota, by the way. So hacker in residence here at Vox 51. Been here for a little over 2 years. Prior to this, I was at various other startups, working in developer tools. And before, going to startup worlds, I was a data scientist myself. And before that, an actuary, biostatistician. And just deep learning has been what I've been doing over the last 4, maybe 5 years. I'm losing track of time. Follow me on GitHub if you guys are curious about what I'm up to and what I'm working on. GitHub's going to be a place to kind of stay up to date with all the stuff I'm hacking on and building, and I'm doing stuff in open source. So this is a good way to keep tabs on what it is that I'm up to. Other ways you can connect with me, hit me up on LinkedIn, on GitHub, on X. I'm trying to grow my presence on X. So if you guys are on X, please do follow along with what I'm talking about and sharing there. So there's gonna be two kind of parts to this presentation. First, slides. I know some of you are like, oh, when do we code? We'll get there. We'll get to code. But the thing is, I want to build a good understanding of what GUI agents are, understand the data challenges, and talk a little bit about the model that we're going to play with in this session. This is a useful context, to get into the code. Then we'll get into the code, and I'll show you how to use FiftyOne for data curation type of workflows. So here's what we are going to cover today. It's kind of meta in a sense. We're going to be using FiftyOne in the workflow to show you how we would go about training a model that could use FiftyOne. And so kind of a meta task that we're working on here. And then we're gonna do a crash course in GUI agents, what they are, how they differ from kind of general vision language models, and I'll discuss why standard VLMs fail at the GUI task, then deep dive into data. Just driving the point home, data. Talk about some common data sets out there, the challenges that I faced, and some lessons learned. Then talk a little bit about this model, GUI-Actor, which is a model that I like. I know it's, there's been a huge boom in this space of GUI agents. And GUI-Actor is a little bit of an older model, but I like it for a particular reason, which you'll see in a little bit. And then finally, we'll get to code, build a data set, generate synthetic data, and then set our data set up for fine tuning. We're not actually going to fine tune a model. Like, I'm not going to go through this, the actual fine tuning of the model, but we'll set you up for fine tuning. Like I mentioned, we are going meta. We are going to train a GUI agent that can interact with the FiftyOne application. So that means I want to try to get a model to navigate menus, click buttons, understand the interface, all through kind of this visual understanding. Yeah, meta task. I think it'll be interesting, fun to see. I'll talk about how it is that I built this data set, and I'll talk about how we can generate synthetic samples and all that stuff. Driving the point home, data is everything. Architectures matter, of course, training strategy matters, but if your data is wrong, then none of those matter. So we're going to drive the point home throughout this workshop that data is super, super important. And there's going to be like kind of a complete pipeline. So what I did was actually, I built a tool and a kind of annotation format that's called Cocoa for GUI. And my hope is that it is solving a lot of the challenges that I've seen with various data sets that are out there, specifically with respect to standardized format. So my grand vision is one format, all data sets. And then I built a tool that kind of makes it easy for us to import this into FiftyOne, and also a plugin for FiftyOne that is used for generating synthetic samples, so help us kind of bootstrap, data collection and just our volume of data kind of at scale. And then talk a little bit about this model, GUI-Actor. But that being said, we're well primed for what's ahead in the next hour or so. So what is a visual agent? So I just want to talk about what I mean when I say visual agent. It means a lot of things to many different people, but I think at the core of what it means is that it is a system that is able to perceive its environment visually, make a decision based on that visual input, and has some type of goal orientation in its actions. Right. This is distinct from kind of a traditional LLM in a sense. That we've seen LLM agents previously. In this case, we're not limited just to text. We're processing visual information. We're operating in a visual environment, and we're taking actions on that environment. You can see here, this could take many different applications, right? Broadly speaking, it's any system that sees, decides, and acts based on visual inputs. And the common thread on, amongst all of these different types of visual agents is that they process visual inputs, understand the environment, potentially plan a sequence of actions, and then executes those through various kind of tools that it has at its disposal. And what I want to do is focus on a specific type of visual agent. This is a GUI agent. All right, so now we're kind of narrowing our scope here. What do I mean by GUI agent? This is something that is going to take a input as potentially a screenshot of your desktop environment, mobile environment, tablet environment, just any type of operating graphical user interface environment, operating system environment. It's going to identify the elements that are in that environment and then output a precise coordinate for the action to be taken, as well as a label for that action and any other kind of metadata associated with that. So it's going to see the screen, understand the required action, and then execute at the correct location on the screen. And in general, we could think of these type of GUI agents as being built upon three key components. There's the environment, of course, which is specific to the platform they operate on, whether that's Mac OS, Windows, Linux, iOS, Android, tablets, like so on and so forth. There's the observation space, which is just all the information that this agent can access about the system state, and it's doing so primarily through a GUI screenshot, graphical user interface kind of screenshot, and also some textual descriptions. Then there's the action space, which is just a set of actions that this model is able to take. Right, so you can think of the pipeline as being something like what's shown on the screen here. There's the perception of the environment. There's some structuring for kind of how we prompt the model to execute a task. The model does this inference, and then it'll execute some type of action. So just real quick, I want to talk about a distinction between a visual agent and a vision language model, like a vanilla vision language model. So vanilla kind of general vision language model, this is great for doing things like, understanding visual content, describing what they see, captioning images, visual QA, and object recognition. But they can't really take action in the environment. There's no real state maintenance across interactions. They're not necessarily goal-oriented, and they're kind of passive observers. But a visual agent is a little bit different. So they're trained for this active interaction. They can affect their environment, and they're not just observers. And so there's this core distinction between the visual agent and the vision language model, right? Driving the point home again, it's perceiving the environment, making decisions, taking actions, observing the results, and repeating. And it's actually interacting and acting, while a vanilla kind of VLM is just going to understand and describe. But to get to this type of agency that we're kind of touching on over the last few slides, they need to master some skills, right? So UI grounding, this is a foundational capability The agents need to map an instruction that it gets to kind of a precise visual element on the screen. There's also OCR, of course, for extracting text from visual elements within GUIs. There's screen understanding, so interpreting the overall kind of content and layout of a screen, and then the action prediction, so determining kind of the appropriate action to take. And you think about actions when you're working with a GUI. You can click, you can drag, you could hover, you could input text, you could do all these different types of actions, right? So that's what I mean when I talk about the action space. So if we take a look at this particular data set, this is actually a data set called RICO, and we had this data set parsed into FiftyOne format and posted on Hugging Face, so you can go ahead and check that out if you're interested. And I'm curious if we were to just take a look at this and, think about the characteristics that we notice about this type of data set that might make it difficult for a regular VLM to perform well in this environment. Take a moment, drop your answers in the chat. I think now's a good time also to let you know that if you guys have actual questions, use the Q&A widget because that'll build a queue of questions if you hit the Q&A widget. But take a look at this, and if anybody has any answers, go ahead and drop them in the chat. But I'll carry on, right? One thing, of course, is you notice a lot of structure, right? We notice that elements in a UI, they exist in a hierarchical kind of relationship, and the groupings of things on that UI matter. So what does that mean? That means spatial dependencies affect meaning. So a button's function kind of depends on where it sits relative to other elements in the UI. There's also the issue of resolution. Typically, a vanilla VLM is going to downscale an image to maybe 224 or 448, something like that, right? But when we do this type of downscaling on a image that is very text heavy, then that text becomes hard to read for a model. But of course, understanding text is critical for being able to function in a GUI. We see a lot of icons, images, and diagrams, and of course, this is going to lose meaning when we downsample. You think about the size of some of these icons, like just looking kind of, if you're able to see my mouse here, right? You look at this, set of buttons here, right? Like, look how small they are relative to my entire screen, right? Look at this text here, how small it is relative to my entire screen, right? It's such a small proportion, right? And it needs to be able to act, right? If I click here, right, it doesn't necessarily close that, right? If I click down here, if I'm off by just a few pixels, the action isn't complete. So what this means is that models need to detect and process really tiny elements on the UI accurately. It needs to be able to maintain some fine details when handling larger images. There needs to, be kind of this balance between preserving information, but also being able to process such large inputs efficiently. So I touched on it, hinted on it, I guess why vanilla VLMs fail as GUI agents. But just to drive the point home, it's about data, right? So to train a robust visual agent, we need specific types of data. And we're going to dig deep on this data over the next several slides. But as a bit of a preamble, there's two kind of ways, particular ways, specific ways that a vanilla VLM, if you just try to use that as a GUI agent, is going to fail. One is just this lack of kind of an explicit spatial inductive bias. A standard VLM is going to generate its coordinates as a text token, right, through the language modeling head. And it does so without any explicit spatial supervision. And this is going to be inefficient, and we get an indirect mapping from the visual features to the spatial locations. Then there's this issue of the granularity mismatch. So VLMs, like the transformer backbone of a VLM, it's operating on a patch level feature, which are typically 16 by 16 or 14 by 14. But a GUI interaction, like I mentioned before, requires really precise pixel level coordinate generation. And so this kind of mismatch, it's a massive gap between kind of the coarse visual representation that a VLM is trained on and this really dense coordinate space that's needed for kind of accurate action in a GUI environment. And of course, this all comes down to training data distribution. So VLMs, like I mentioned, are trained. Well, maybe I didn't mention it, but I'm mentioning it now. VLMs are primarily trained on natural images with captions, not a whole lot of GUI screenshots with really precise coordinate annotations. So visual patterns, spatial relationships, interaction paradigms in this environment that you're even looking on the screen here is fundamentally different from a natural image. I'm going to turn my attention to the chat and the QA widget here, and I'll see what the question was here. How big does the dataset need to be for a company's component library usage to be accurately detected in their product? There's only one right answer here, and it depends. So I don't have a answer like one size fits all answer for that. It depends on the model, depends on the model that you ultimately end up fine tuning. If it was trained on data that's quite similar, but you know what? I hope to kind of give you a sense of how much data you need when we get to the coding section, right? So just stay tuned and let me know at the end of the session if I end up at least giving you an idea of what's necessary. But continuing on, and driving the point home again, resolution, right? We talked about resolution challenges, natural images. Well, think about it. Think about the resolution on the screen you're looking at right now, or your phone screen or your tablet screen, right? The resolution is actually quite high, right? It's a lot of information on the screen, and the components that we need to interact with, like I mentioned, are very small icons, small text, small buttons that make up a small proportion of the entire resolution of that image. And so, of course, this is challenging, especially for a vision transformer. Vision transformer, as you know, they have like a quadratic computational complexity with respect to kind of like the image size. So when we process high resolution GUIs, it just becomes really, really expensive computationally because we're working with such large images. And then there's this difference in scale, right? We got different, like look at my screen right now, like as an example. The scale is different. We've got large header text, smaller text. We've got small text up here for these tabs on the browser, and even up here on the menu bar. And these icons are small, right? Like there's just this very kind of a dramatic distribution of scale of elements just on one screenshot. Question here, GUI actions don't really need a pixel level accuracy. Is it enough to understand the element rectangle and the heuristic of where to click act? Well, here, point in case, right? If I try to click on this button here, and my intention is to click on that button, right? Like you can see, like I tried to click on that button, and if I was off, I changed, the slider. If I click right here, look, I'm clicking as hard as I could. I'm off by a pixel, but I'm still not taking the action, right? So yes, pixel level accuracy is essential for operating in the GUI, right? If I try to click this bookmark button and I'm off by just a pixel, then it hits profiles, right? It just driving the point home, right? Try to be off by a pixel or two on, a mouse click and then see what happens. Can it be made to operate in noun browser? Yeah, I mean, I'm talking about any type of GUI in general, right? We're completely agnostic to any application. If it's on a screen and you can interact with it, then of course, I'm talking about that type of data, that type of agent. That's what we're interested in here. We're talking about GUI agents that operate in a graphical user interface. I don't care if it's a .NET Windows legacy application. Yeah, if you're operating on a screen, then that's what we're dealing with. Sorry for ranting. All right, so OCR is hard for GUIs for a variety of reasons, as mentioned here on this slide. Um, uh, Another question, I'm just going to address this. The question coming in here, would it better not to be based on, would it be better not to base on a screenshot rather than GUI rendering like Wayland or X? I don't know what you mean by Wayland or X, but if you're talking about operating in token space, then my argument for operating in token space is that a pixel is worth 1,000 tokens, right? We want to be able to operate natively on pixel space, not token space, because again, tokens are hard to process, eats up context window. And if we think about achieving human-like actual interaction, we would want an agent to act in pixel space. So, we're constraining ourselves to agents that operate in pixel space rather than token space. So yes, OCR is hard for a number of reasons as mentioned here, and just kind of moving on. And I think I'm answering some of the questions that popped up into the chat and the Q&A here. Just teaching AI where to click is hard, right? The model has to convert what it quote unquote sees into an exact coordinate for reasons I just demonstrated earlier. But is there a direct connection between understanding a login button and knowing where to click? Right? We need to build that in through training data. Some systems are rigid, as we've seen. They demand an exact click point. For example, like an icon here, right? You can see we get like a little bit of a radius on where we can click, and that action is still viable. But if we click on a login button and we're off by like just a pixel or two, and it's not on the button, then nothing happens, right? So teaching it where to click is hard. So here's a question coming in on the chat. Are we talking about games? That is a type of visual agent, but as I mentioned at the very top of the hour, we're talking specifically about agents that operate in a graphical user interface. Yeah, so that's what we're constraining ourselves to. Make the case argument here that kind of most VLMs treat a GUI just like a regular photo. If the predictions are a few pixels off, maybe it still gets a reward, but like I mentioned before, GUIs or interacting with a specific region on an entire screen, not maybe not general coordinates. It needs to be kind of precise. Not only that, it needs to understand where elements are relative to each other, right? So understanding spatial relationships is important. As you can see on any screen that you are using, there's a lot of elements packed very, very densely on a UI. Button touches, icons overlap, and if we're trying to click a checkbox on a form, but we hit an adjacent one instead, then it's doing the wrong thing. So there's kind of this binding problem that happens. So GUI agents they need to actually correctly be able to associate a text label with the corresponding kind of interactive element so that it could perform that intended action rather than just like doing something wrong. And so, I argue that these type of models, when we train them, they need a loss function that really teaches them to find and match a appropriate region and kind of have this IOU aware loss. But we're not going to talk too much about that because, of course, like I mentioned, the most important piece is data. And so we need several types of data, and we need data across a wide range of platforms and applications, depending on how general you want that visual agent to be. You need annotations. You need to describe interactive elements within that screenshot or within that screen. And it's foundational. It's important. It's all about the data. So let's talk about some type of data that we'll need. So here, this is a data set here called Mind to Web, and we've got a parse in the 51 format on Hugging Face for you here. But just to talk about the types of data that we need or the types of annotations, of course, we need GUI grounding. So we need to be able to map a instruction, a prompt to a visual element. And we need to be able to do, of course, OCR. So being able to extract text from the GUI, understanding the screen as a whole, so the overall layout of that screen, how its content is organized on that screen, and the different kind of structure of that interface, how different groupings of buttons or icons map to one another, and then of course action prediction. So right, determining what the next step is. This is from another data set we've got parsed in 51. It's called a GUI Odyssey. I'll drop the link here. And in terms of how much samples we need, well, like I'd say we need orders of magnitude more annotation effort than a natural image data set. You think about a screenshot or just any GUI environment that you're working with, you might have 200 interactive elements, and each of those would need some, at least for if we're trying to teach train a general purpose model, like we need bounding boxes or click points on each of those elements, and kind of a description of the task that accomplishes. So we can't just draw a box around a button and call it a button. We need to give the instruction, submit the button for the login form at this exact coordinate. And so collecting interaction traces, of course, means that we, if you want to train a model to like actually perform a task and do a sequence of tasks, then you need to record sequences of data. And like I mentioned, every pixel does matter. This is a data set here called, I believe this is Screen Spot, but the point I want to make here is that depending on the type of GUI agent that you want to train, if we think about, for example, like a Claude Code model, which is able to interact on a GUI, that type of model needs diverse coverage, diverse operating system, whether it's Mac, Linux, Windows, different IDEs, so on and so forth. If you're building something that has application that could be on mobile, web, or desktop, well, you need data for that as well as the labels. Looking at the Q&A widget real quick, I see a question come in. Are these models? I mean, yeah, you can find models of various sizes, and you can always quantize them, make them smaller. But yeah, ideally, if you are shipping this out to a lot of users and actually want it to be used kind of locally, then yeah, for sure, that's definitely an issue. So what I'm going to do is I'm going to quickly paginate through the next several slides because I'm going to get to the code, but I just want to drive the point home on the type of data that we need. Element description data, GUI grounding pairs. We need tasks demonstration data. So just like ordered sequences of interactions needed to accomplish a goal. So what that means is screenshots of interface state after each action, like that transition. We need OCR data, of course. And of course, this comes in various font sizes, orientations, and all that. UI rendering with text, for example, OCR with natural images, if that's going to make your model more robust. Just think about the application that you're going to be using that model in, right? Task data, specialized task data, different types of augmentations, need to incorporate that. Bounding box annotations, I think arguably probably the most important, not only bounding box, but click point, key points with the actual instruction that that element of the screen does. And the limitation is there's just not a lot of publicly available data sets that give a solid starting point. And for those that do exist, they might not have sufficient coverage with the diversity of GUI environments and applications that are out there. And I just want to give you a quick overview of some data sets that are out there that I've come across. And like the point over the next several slides is pay special attention to the annotations that we have, and tell me as we go along through this, like, do you notice any type of consistency, right? That's a key challenge that I faced when working with this type of data across various papers that were publishing data sets. So I'm going to look at a bunch of different data sets and just take a look at first the type of data that you see, as well as the native annotations. So here, if you take a look at the annotations here, it's like a nested JSON tree with Android UI components, action spaces, Android specific. Here, GUI Odyssey, we have episodic data here, so episode based with ordered interaction step. The action space here, click, long press, scroll, text, back, recent. You know, the format actually, if you notice, of the interactive elements are actually different from the one we just saw previously. GUI-Act, again. Here we have the annotation type. Yes, it's JSON, but it's not quite standardized. Mind to web, notice the JSON and notice the type of data that we have and the different resolution. Show UIs, another data set. And by the way, these are all on our Hugging Face org. And this one is an interesting data set because it was like kind of unified in the sense that we had samples that were across desktop, web, and mobile. So it was really kind of trying to head towards this platform agnostic interaction. ScreenSpot Pro, this was a data set here that's just using like professional applications across various operating systems. But again, just look at the differences in the annotation formats that we see. Another one here, ScreenSpot V2. You notice that we've got iOS devices as well as some Android and things like that. But again, the annotation format, not consistent. Same thing with Ground UI, right? Not really consistent annotation format. And of course, you could check all these out here on the FiftyOne Hugging Face org. Profil, I see your question, but it's quite long, so I'll come back to it at the end if you're still around. So if you notice any patterns, I think the biggest pattern was that there really was no actual pattern amongst the annotations, right? Working in computer vision, like, we're used to standardization in terms of annotation format, whether that's Coco, VOC, Kitty. It just makes life easier when we have this type of consistent annotation format. But everything we saw uses a different coordinate format, different coordinate system. For example, like absolute pixel versus normalized pixel. And then we had different names for the fields for different, the same concept, bounding box versus like B-box versus bounds versus bounding box rectangle. And so it's really fragmented. And so, of course, this makes it kind of difficult to combine data sets and build like a unified trading pipeline, right? If let's just say you're pre-training from scratch, right? You imagine you as a researcher and engineer pre-training from scratch, and you have data sets that are in the multitude of formats that we've seen, just trying to, build a PyTorch data loader to handle all of those it's just going to be a nightmare. And there's also this inconsistency in like action space representation. So we saw that on GUI Odyssey. We had some really kind of clean typed base structured, but then GUI-Act had like kind of XML coordinates, XML-esque coordinates, and there's no real unification in terms of like the action representation. And there's a lot of critical information missing. For example, at least in my experience, amongst the dozens of data sets I've seen some that lack essential metadata that would be really helpful when trying to train a robust GUI agent. timestamps, for example, for action sequences, application state context, success or failure. A lot of hierarchical information was missing. There's just a lot of chaos, I would say. We talked a little bit about the coordinate systems, but yes, that was an absolute pain, right? So I want you to just imagine from the perspective of like a researcher or engineer trying to build a training pipeline, and you want to rely on external data, and just how painful it is to try to parse all these different data sets. And so, of course, this introduces several challenges, which I want to briefly touch on. Question coming in here: would training a model only on a specific OS or even specific application make an OS make it more efficient? I mean, it depends on what you're using that model for, right? Right. If I mean, I'm guessing most of us are building, like, the context that I started this session with was I'm going to build or what type of data do I need to build an agent to interact with 51, right? So in this case, I just need a ton of 51 screenshots with labels and annotations, right? Like maybe you work at yourawesomeapp.com and you want to build an agent that only works on yourawesomeapp.com, then yeah, you just need data for that, right? We're talking about from the perspective of fine-tuning data, so that's what I mean there. Are there any models good at generating training data sets? I wish there was, and I'll talk about how I generated a training data set and the painstaking process that took. So I will. Are there any AI? I guess, since I am of Indian heritage, there was AI actually in Indian, and maybe I'm good enough to be a model, good looking enough to be a model. Is an actually Indian model like myself was generating these data sets. All right, go now. All right. Hopefully, no, that didn't offend nobody. But yeah, challenges, right? Talking about the challenges that those issues present. Of course, loading all that data, pain in the butt. Trying to build a training pipeline that can handle that consistency, absolute nightmare. That, of course, introduces engineering overhead, right? So this is pain. And so I have tried to solve this problem. It came to me in a dream, Cocoa for GUI format. So not only did I invent this Cocoa for GUI format, I vibe coded an application that will help me collect data to train a model to interact with 51. So I'll drop links to this. Well, in the GitHub repo, like there'll be a GitHub repo linked, and that GitHub, when you get the email, that GitHub repo will have all the information. I'll send it as well in the chat in a second. But it was just such a nightmare. Like there was no tool that I saw that would help me collect the data that I needed, much less give me that data in a consistent format. So I kind of invented it because I needed it, right? So I said, all right, I'm going to create this web app. This web app is going to let me capture screen interactions. I'm going to define the action space up front, and then I'm going to have it output in a very consistent format. And so this is what I invented. And I was at a conference actually quite recently. Well, it wasn't recently, it was in Europe. And I was talking to a bunch of researchers in this space, and like people were like, oh yeah, I actually came across your tool. It was helpful and I used it. But we'll see if I get citations or not. But this is kind of my contribution to the space. So I built this tool to collect a data set, and this data set has a consistent format, this Cocoa for GUI format. So it's one format for any data set, and there's just single standardized schema. And so, of course, this gives you a lot of compatibility with existing tools and infrastructure, right? Because everything is in like a Cocoa-esque format. We all know what Cocoa is. We all have a mental model of what Cocoa is, and we have an understanding of kind of how to parse that, build our PyTorch data loaders using this format, right? It just makes life easier. And so I kind of just invented what I wish existed. Um, and another issue, of course, is okay. So like doing this process of like creating data, like I'll go to our Hugging Face org just to show you the actual data set that we ended up that I me myself ended up building was is this data set, and a GIF should load here, hopefully, because I thought I put a GIF in. No, there's no GIF. All right, cool. That's my bad. But you can see here, like I've got these. I manually, what I did was I used this the tool that I built. I plugged it in. I took my laptop, changed the resolution on my laptop, used my iPad as a second screen, used a bigger screen. Like I just was switching around resolutions and capturing the screenshot and then manually going through and annotating things one by one. And it took me, it was like my full-time job for like 2 weeks. I'll just show you the data set since I've already got it loaded here. I didn't need to go there. So it took me like just like labeling here and mapping out the task descriptions. Like the tool I built kind of it did help because I cached like a lot of the things I used previously, so I was able to kind of speed up the process. But even then, this was something like not even 750 samples. Like it took me 2 weeks to do this process. Took me 2 weeks to do that process. Um, and so I ended up just saying, okay, I'm just going to generate some synthetic data to kind of scale the creation of or just scale my data rather, right? And so I built a plugin for FiftyOne. So there's a couple things that I need to link you to. Um, I think it was, if we go to my GitHub, go to the GitHub here. If I type in GUI, I'm going to link you to this. All right, cool. So I'm gonna link you here. Here's the tool that was built. Uh, Nick, I'm hoping you're extracting these from me so we can email people. But this is the tool that I built, Cocoa for GUI. And then to import it into FiftyOne format, we'll see this in code a little bit later. I just realized I'm dropping links only in the host and sorry about that. I was dropping links the entire time and they weren't getting sent out. Anyways, synthetic GUI samples. So this is a plugin for FiftyOne. So of course, FiftyOne is open source, hackable. Those of you who dropped FiftyOne in the chat know about this, right? And so I built a plugin that helps scale data, synthetic data. One of the operators in this plugin is just resolution scaling, right? Just being able to simulate a wide variety of different resolutions out there that people might use, whether they're on a laptop or a tablet or whatever, what have you, right? The different resolutions that are out there. Another thing this does is simulates color inversion. So trying to get my hypothesis was like, if I'm generating synthetic data, then what I want to do is actually simulate an environment for people who are colorblind, right? So one thing that this synthetic data plugin does is that we can scale data curation by simulating color blindness. So there's a bunch of color blindness here that that we can simulate. Wait, this was the color inversion. This just inverts the colors. This is the color blindness, yes, and grayscale as well, just because I was thinking that we want a model to be robust enough to learn where to interact without having to depend on colors. Because of course in FiftyOne you could do light mode and dark mode. So why not try to have train the model to be robust just by kind of removing color from the equation. Of course, when I was collecting the data, when I was curating and building the data set, I actually like toggle between light mode and dark mode manually as well to make sure it just was capturing enough. And then of course task description, right? So the hardest part was, one challenging part was like describing the task. And so built a operator within the plugin that would just create synthetic samples, might be the same exact screenshot, but then it'll just rephrase the task so that we have more variety in terms of how a task is expressed. So all this together just kind of synthetically bootstrap a data set. And so it ends up looking something like this. So I was just very quickly, after a couple iterations with that, scaled from something like whatever was 740 samples to like 4,000 samples. So very quickly was able to do that. Yeah, but we'll get to this in just a second. So that's it. All right. So far, like my contributions to like this challenge that I was facing, or the challenges I was facing while working with pre-existing data sets, was build a way to collect this data in a consistent format, come up with that consistent format, Cocoa for GUI, build an importer for that so I can ingest that data into FiftyOne quickly. Then find a way to bootstrap data by building a synthetic samples kind of plugin to generate synthetic samples. So this is like the way I kind of overcame a lot of the challenges that I was seeing in the data sets I was working with, as well as like my own just doing the work. Going to the Q&A here. Are LLMs out there like Claude, OpenAI models simply not? Yes, they are capable, but those are massive models that we are never going to be able to, first of all, access. Second of all, run locally, right? So, yeah. What practical value does a custom model bring versus Claude, for example? Well, Claude may not know your specific application and like perfectly, right? Like I've worked with Cloud Code, trying to have it interact with FiftyOne doesn't do the best job on the app, right? So that's one thing. Second thing, of course, like if you want to have it run locally, then we need to have the model small and local. If you care about data privacy, of course, we need the model local as well. So hopefully that gives you the practical value that you are craving. Why not leverage HTML? I think I talked about this before. A pixel is worth 1,000 tokens, right? Why operate in language space when you can just operate in pixel space and take the action directly, right? Why flood your context window with all the entire DOM structure of a screen when you could just look at the screen and interact on it? You know what I'm saying? So I talked about that before. Let's keep going. All right, so we talked about the data. There's a ton of model out there, a ton of research. A lot of it's new, a lot of it's awesome. It moves too quick for me. But the model I really, really like is a model called GUI-Actor. And I'll tell you why I like GUI-Actor. First of all, it's nice. It's open source, built by Microsoft. Backbone is Qwen 2.5 VL. Hopefully they update it. I'm looking forward to them having it with Qwen 3.5 VL. But what I like is just consistent output format, right? It doesn't do anything except just like give you a predictable key point, but also an attention map, right? So we bypass the pitfall of inconsistent output formats like bounding boxes versus coordinates versus descriptions by just a simple key point. And it outputs what it really outputs is PyAuto GUI commands with the coordinates, like the pixel coordinates, but then additionally just the built-in explainability, right? So you can see kind of where the attention map for where the model thinks it should interact given the command. The model comes in two sizes, 3 billion parameters and 7 billion parameters. So small enough to run local. And there was not a lot of hackery or black magic that you have to do with system prompts, because you just use the exact system prompt from the model card and vary the task, and it gives you decent performance. It's a nice model. I like it. I'm not going to go too deep into this, but of course, it solves for grounding GUI agents. So it helps kind of pinpoint exactly where to interact on the screen. Um, and so it mimics humans. Uh, we're not calculating coordinates. We're not like traversing a DOM tree when we're trying to interact with the GUI. We just perceive and interact. And this is kind of what GUI-Actor is meant to imitate. So like I mentioned, built on Qwen 2.5 VL, and then it has some specialized components. One is this token called the actor token, which is like a special token that encodes the intent of your action by combining it with the action in the screenshot. We got this action-based attention head that gives you, in addition to the command of the coordinate, just a attention map to kind of tell you where it is that the model thinks that it needs to interact. And so we have visual patches that undergo some type of self-attention, as we can see here. The model is going to compute some attention score between the intent and the visual patches, and then it's going to create a heat map that shows kind of how important it thinks that region of the screen is, given the command and what it sees. There's this thing here called multi-patch supervision, and this just trains on an entire clickable area rather than a single point. And so it's kind of similar to how a human would interact. There's another model that came along with it that was a grounding verifier. But kind of main thing is that we use Qwen 2.5 VL as a backbone, a lot of general knowledge. They added only 100 million parameters to build this model. And with that small amount, they were able to teach a direct visual way to understand kind of where to click. So think about how we would customize this to use FiftyOne. As I mentioned, there's significant challenges that you would face when working with this type of data. And so what I did was kind of summarize what would need to happen. So in FiftyOne, we need to store the UI interaction as key points and bounding boxes. And GUI-Actor is going to expect some type of JSON format with specific message structures. And then, so we need to create some type of a layer to kind of transform FiftyOne annotations to what GUI-Actor needs to see. These are just implementation details. Actually, I don't want to go too much over this. I just want to jump into the code. And so this is all talking about, you'll have access to the slides anyway, so it doesn't matter. We're not going to fine tune, but if you were to fine tune, follow this recipe. And now I'm just going to get into the code. All right, cool. Because we've been talking about slides. So this is the code base we're going to use. It says ODSC because I gave this at ODSC recently. Screen was changing fast and often, and that's because I was just like powering through some slides, but we're going to slow it down now. So if you go to this repository here, this notebook is what we're going to go through. And so I just converted this notebook into kind of one-by-one slides so that we could talk through what it is that we're going to do. All right. What's this question in the chat coming in here? Screens with hyperactive interaction seem to be looped recordings.
It's 12 o'clock.
Okay. Yeah, well, that's good to know that those GIFs were distracting. So apologies. But we're going to continue on. Cool. So now we're going to talk about kind of the data set that we're working with and kind of how I use GUI-Actor to help me curate a data set. So preview what we're going to do over the next 30 minutes. I'm going to try to power through this. Give you a brief tour of FiftyOne because there's specific language and things we need to know about FiftyOne. So understand the tool that we're going to use for dataset curation and visualization. Show you how we can load that data. Then we're going to do some just simple analysis, high-level analysis. We'll compute embeddings on the data set that we have. We'll show you how to run inference with GUI-Actor, show you how to evaluate initial model performance, and then how we can use that initial model performance to help us figure out which samples are priority samples for us to go and build a training set with, and then talk about generating synthetic data, and then of course show you how to build a torch data set from the FiftyOne data set. By the end, you'll hopefully have a systematic workflow for how to curate a high quality training data. So there's some prerequisites and installation for installation. The GitHub repo will have all that information. It is here. I'll push a couple of changes to the requirements that I noticed. But anyways, simple installation. And right now, I just want to give you a tour of the FiftyOne app. So looking at the FiftyOne app here, there's different things that you could do in FiftyOne, and each different area of FiftyOne has like its own name, right? If I wanted to refresh the data set, I would click on this, right? If I wanted to find another data set that exists, I would click here, right? If I wanted to hide the sidebar, I'd click there. If I wanted to filter key points based on label, then I would click here. And so what I was trying to do is, okay, how can I teach a model? If I was to build a data set so I could fine tune a model to teach it how to interact with FiftyOne, I would need to encapsulate all this information, right? If I wanted to open an embeddings panel, I would need to click there. I would need to click on embeddings, right? If I wanted to go to the samples panel, I would need to click there. If I wanted to build a dashboard, I would need to click there, right? So there's different things that you would want to build into a training set to teach a model how to interact with FiftyOne. So that's just a really brief tour, right? If I wanted to open a sample, I'd click on it. If I wanted to hide the sidebar from the sample, I'd do that. If I wanted to show the sidebar, I'd do that. If I wanted to do any number of things, right? Where would I click, and what action would I take? And so all of these samples here represent that, right? If I wanted to, for example, toggle query performance, that's the task description. What's the action type? Click on that. That's essentially what I was encapsulating when I was building the training data set. So if those of you who aren't familiar with FiftyOne, it's just an open source library, pip install FiftyOne, and it's a tool kit to help you build high quality data sets, because without a high quality data set, you can't build a high quality model. Quick start way to interact with it is just using our quick start data set. So that's something to note if you want to just kind of play around FiftyOne. So as I mentioned, to create the GUI dataset, I built a tool, the GUI dataset creator tool, and I've already kind of given you a preview of how that works, so I'm not going to go through this live demo part here. But essentially what I did to create the GUI dataset was I used this tool to capture screenshots of FiftyOne, and then I annotated bounding boxes around the UI elements. I marked click points, and then I added task descriptions and various metadata. And then all of this was collected in a standardized format, which I called Cocoa for GUI. So we've talked about that already. Now, in order to load Cocoa for GUI into FiftyOne, we first need to actually download the data set. So that's what this code here does. So if you were to run this cell of code, it would download my exact GUI data to your local drive, and I think it's something like 2 or 3 gigabytes of data. So it's quite large because the resolution is quite high of each one of my images. So you download that data, and then what I did was actually showing you here what the annotations look like. So you can see the different keys and the number of images that I had, the number of annotations, and the categories, right? So what we're doing here is we're just kind of inspecting with Python what the annotation file looks like. You can look at what a random image looks like so. And of course, this is kind of why FiftyOne exists, is so that, well, one of the reasons, I guess, not why it exists, but one of the things that it helps you streamline is just seeing your actual data and your annotations all in one place. Otherwise, you'd have to write code like this and kind of manually go through all that stuff and not really have the type of interactivity that you could with FiftyOne. So this is kind of showing you a brief intro as to what it is that we're working with. And then I get into Cocoa for GUI format. So we talked about this already, but standardized format. And then I built this importer so that you can very quickly and easily import the data set that you just downloaded into FiftyOne. So the way you do that is once you clone or just get that definition for that importer, it's just a simple one method call to FiftyOne. And the dataset type is a code for GUI dataset, and then we end up with the dataset loaded. So a sample in FiftyOne looks something like this. So in FiftyOne, like the core object, central object is called a dataset. This dataset is comprised of samples, and samples are comprised of fields. And a field on a sample has not only just the file path pointing to where it is that media lives on disk, but also associated metadata as well as the labels and annotations that you have. Right, so just brief conceptual explainer about what a sample is. And because FiftyOne is actually backed into like a MongoDB database, you don't need to know anything about MongoDB, but it's kind of built on top of MongoDB. What that means is that you're able to do these really complex and non-trivial slices and dices of your data set with just a few kind of lines of code. And so I want to show you a few interesting things that we could do with FiftyOne. It looks like S3 data. No, this is local data. Yeah, I mean, it's just those are local file paths, not S3 file paths. So we could do some initial data set analysis by, first just extracting all the values from a particular field. And in this case, what I'm doing is I'm getting like the number of counts for bounding boxes and points, right? And what we could then do is like once we have this information, right, we got this as a field on our data set, the number of box counts and number of key points. We could then build a. This is the data set here that actually I'm supposed to be pulling up. GUI workshop data set. We can get this sample has no bounding boxes and this sample has 19 points, right? And so then when we open up FiftyOne, we can go here, we can go to dashboard, we can add a plot, we can make in this case, we can make it a categorical histogram. We can have the categorical histogram be, let's do something more interesting. Let's do like the distribution of key point labels. Right, so we create that, and it, we can write all of this stuff in code that we're doing there. But of course, in FiftyOne, you can just make a dashboard as quickly as that, and then it's like interactable. So then you can just like filter down to only samples which create which contain hover as one of the key points. So if we wanted to add another dashboard here, we just add an item, go here. Maybe we want to do a numeric, not numeric histogram, a scatter plot to look at the resolution of the images that I've got, height and width. That makes sense. All right, so we can do that. Let me just clear that from the view bar, clear that query from the view bar. I can see here that I've got a variety of images across a wide variety of distributions. Like if I want to just like say, okay, what are all these samples here? It would filter it down automatically, and so that dashboard plot would change as well. So what we're doing here is we're doing some initial EDA, some initial exploration of our data set, and it's made quite simple using FiftyOne. And of course, what I was trying to do when I created the data set was trying to teach a model how to do these things as well. So you can imagine me painstakingly creating sequences of actions and trying to annotate the data properly to get it to figure out what to do, where to do it. But essentially, this is how we would use FiftyOne to explore and understand a data set. So you could do it via the SDK or right there in the app. So via the SDK, if you wanted to get a distribution of detection labels, of course you could do that. Or you just come to the dashboard, add a plot, We can say categorical histogram, detection label, sort it by frequency, create the plot, clear that filter, and we could see, okay, there's this many click points, or sorry, there's this many hovers, and so on and so forth, right? So we're able to build that out. Of course, you can see it, like it maps right to it, right? 570 hover, right? 570 detections with the label hover. Right? So of course, we could do even more complex filtering and querying with FiftyOne, so that we're able to just create slices and dices of our data set. So here is a non-trivial kind of filter. And what I'm doing is I'm just filtering I'm creating a filter, and I'll show you what this looks like. But this is anywhere where when I created a data set, I actually forgot to put a task description. So I'm finding missed ground truth annotations in my data set, right? So I create a view on this data set. So I go to here, open the saved view menus, see here, no detection, right? So these are detections that do not have a task description, right? So if I hover here, I see, okay, well, actually there is no task description here. So of course I could, I know now that I've got some problems in my data that I need to go and address. So something I could do is, I can go on annotate here. We got human annotation now. I could go to, I forgot the field name that I was working with. Detections, where is it? Setup detections, right? And then I could define the schema and make changes, or even this annotation feature didn't exist before, but if I notice that there are places where I'm missing some coverage, I can go and add that right here in FiftyOne via the annotate feature. So just giving you kind of a way to show you how we can use FiftyOne to understand our data set for initial exploration, figure out where we might have missed some important annotations, and then of course how we can then enrich our data set with more annotations if we need, because we could do annotation within the app. So I just want to get to the good stuff. This is just filtering, again, just more samples of filtering. I encourage you guys, when you're working at home, to play around with this and see the different views that we end up with. In this case, I'm creating a view of all detections that are just click, where the action type is click. So we can clear this query from the view bar, and then just look at clicks only. There you go. Here, clicks only. So then I can see, okay, these are all of the samples where the action type is of a click only, right? The detections are clicks only. You'll notice that we have other key points as well, but that's fine, because this filter condition is essentially just saying, we're filtering individual labels within the sample based on that expression. So just continuing on and showing you kind of more things that we could do, right? So of course, cursory kind of EDA is fine. It's interesting to do, but it's hard having to scroll through all those images and kind of take in and manually hold in your head kind of like the structure of your data set. Of course, for this, we can also use embeddings to kind of help us understand our data at a more kind of different level. In this case, I chose to use a model called Gina V4. It's an embedding model that actually can support cross-modal retrieval, but it's just one of my favorite embedding models. So simply for that reason, I chose to use it here. So of course, FiftyOne does have a model zoo. There's a lot of built-in models that you can use, but it's open source, it's hackable, so you can extend it and implement and integrate your own models. Of course, contributions are always welcome. Somebody is asking, how do I get a sweet Voxel 51 hoodie? Well, you can get a Voxel 51 hoodie by contributing a integration to a model of your choosing and letting us know in Discord that you've done so. We'll send you a hoodie. But basically, you know, point in case here is that it is extendable. You don't have to be limited to only the models that we have. You can build your own models, model integrations. And so computing embeddings is just a simple one-line thing once you've got the model defined. In this case, I computed embeddings using Gina. And then what I did was, of course, having embeddings is one thing, but then we want to visualize it. So then I used, in this case, UMAP dimensionality reductions over the embeddings to, and as you'll see in the embeddings panel, we're able to visualize those embeddings within the app. I also built a similarity index, and I'll show you kind of what that's useful for. Of course, we can do it for the whole image, or we can do it on the patch basis as well. And so what I mean by patch is like for example, patch would be just like this, right? So I can create a data set of like just like the interaction points rather than the whole image. So go here to embeddings, open the embeddings panel, and look at the, clear that out. And then you can see here that we get some kind of more or less clusters of the different types of images we have. And it's interesting that, you know, even though everything is 51, this data set is comprised of only 51 screenshots. We see some kind of islands of images that we have. So here, if I highlight this, I can see that, okay, these are all images that in one way or another have like, looks like cars of some sort or road scenes. These are all the screenshots with this particular data set, right? So we could see that, you know, I can see if I'm over-indexing on collecting samples of a certain nature. We can see here that these are, this little island are all images where I have this particular sample open, right? Going down here, right? You know, you get the picture, like you're able to now get a sense, much more deeper sense of what this data set is actually comprised of. All right, so it's one thing to get those cursory high-level summary statistics. It's another thing to look at it from this perspective and build a deeper intuition for what it is in your data set. Of course, I did it on the patch level as well. So I didn't create a patches view, but were I to create like a patches view where I just have a data set that's comprised of just each individual patch, we'd see like these are like the interaction points. In this case, these are all interactions here. Yeah. So continuing on, showed you how to explore and do all this stuff. And what I'm going to do next is actually, you know, I mentioned that GUI-Actor works specifically on key points, right? So I decided to take a view of my data set and just create like a key points view. And then I said, you know what, let me just create an entirely focused data set just from those key point views. So that's what I'm doing here. I took a view, I cloned that view so that it's like its own independent data set. That data set is key point patches. And this is the data set that I'm going to work with going forward. And so we're going to be using key point patches here. So we went from our massive data set now to just key point. And the thing to note here now is whereas my original data set had multiple interaction points, what I'm going to do next is just get just one image with one label, right? And I'll show you how we get there in a second. But for right now, all I did was create a data set that has only the key points. And then what I did was I ran GUI-Actor on this data set, right? Sorry. I was slightly confused with my saying there. I already have, after running that code, what this data set represents is it's one screenshot with one sample. Oh, sorry, with one annotation. All right, so I might have the same screenshot as you see here over and over, but the annotation changes with each sample, right? So this way, as you'll see, I'm able to get a better sense of how GUI-Actor performs out of the box. So what I did was with this code is I implemented GUI-Actor as a 51 zoo model, and I applied that on this data set I just showed you. And what I did was apply the data set, and now I've got predicted key points, right? And so you could see the task for this is, where's the task description? It's on the top level here somewhere. Oh, down here. So the task description here is open the color settings, okay? And so open the color settings, this is the ground truth. This is where it should click, and this is where GUI-Actor thought it should click to open the color settings, right? So it's one thing to be able to see this, but I just want to very quickly get a holistic sense of how GUI-Actor works out of the box. And the reason I'm doing this is, okay, ultimately I would like to use GUI-Actor and fine tune it further to work specifically with 51. And GUI-Actor is a decent model. Right out of the box, it does work quite well. And so I really what I want to do is understand where it does not work well, so then I can collect more data for those scenarios, right? So then I can help it build a better understanding of what it's lacking, right? And so after running the model with the task description on the data set, I can use 51 to evaluate detections. So we can go here and we can look at model evaluation. And in this case, I'm just going to look at the key point evaluation, and I get a sense of how well the model performs. You can see here it doesn't perform that well out of the box, as well as maybe it should have. But out of whatever 6,000 samples, it could have done better. But also I should say that I terminated this inference run before before I got through done with everything, because I just running out of time. So in this case, our support is only 2,300 something samples. But we get a sense of kind of how well this model performs. We also get kind of the confusion matrix here. Again, remember I didn't run it on the entire data set due to time. But what I really wanted to do real quickly was get a sense of, okay, how does this model fail, right? So I've got this data set. I know I've done some enrichment to it, or maybe I haven't yet done any enrichment, but I've got an initial data set that I've built, painstaking and time consuming. And I want to make sure that I've spent effort annotating the right things, right? Like I don't want to keep annotating things where the model already does well, right? So if I know I'm going to take this model off the shelf, out of the box, GUI-Actor, I'm going to take this model off the shelf and then fine tune it for my specific use case. Well, then it would make sense for me to figure out where that model does not perform well, and then annotate those scenarios and enrich samples that kind of cover that failure point. And so what I did here was created a few views in 51, looking at where it is that it missed the detection, or missed an incorrect prediction, or provided an incorrect prediction. And then you could do this either by action type, or you could do this either by label type. So there's two ways that I've shown you how to do that here. And I know I've got like 5 minutes left, so apologies. And so what I did was just going to fly through the code here. Of course, you have this, and you can go through it in more detail. But the point what I wanted to accomplish here was I just need a way to figure out what the problematic samples are that I need to review, and then build a training set around that. And so we can visualize the failures here. So you can see here, visualize the failures here. Open up this. We could see, okay, this is, samples where it missed a point. These are samples where it missed a incorrect prediction. This is where it missed, where it should drag. This is where it missed the hovering. This is where it incorrectly dragged a point. This is where it incorrectly selected something, right? So I've created all these views of my data set for the different failure modes that this model had. Now, I mentioned that this actual data set, this actual model will output heat maps, right? So this is interesting because now we get a sense of, okay, where the model thinks it should interact given the command. So I'm going to unclick this predicted key point, and now I have the ground truth and the heat maps. Right? So if I have the ground truth and the heat maps, I could kind of get a sense of how far off the model was thinking where to interact, right? Because exact click points, like, like you can imagine, right? Like I can interact anywhere on this entire button and the action is valid. But if the model predicted clicking here and really it should have, and the ground truth is there, like it's still performing the action, but it's being penalized and marked as incorrect because it's not exact. So I said, okay, let me leverage the heat points that the model produces so I can get an insight into what is actually a failure. So you can see here the model, you can see the point where it clicked was off by just a little bit, right? If we scroll in, the point's off, so it's going to be marked wrong, but it had an idea of where to click, right? And so what this block of code is going to help me accomplish is figure out whether the model was thinking in the right direction, right? Like if the ground truth key point lands within a lands within the heat map region, then I know the model was doing somewhat decent job of understanding that task and can perform that task. I'm more curious about where it was not performing well, because if I know where the model is not performing well, then I know that that's more data that I need to collect for that type of task. So I guess the code isn't. I'm not hacked together this thing where I can convert a notebook into a slideshow, and I can see now that there's some things I need to fix. But that's what this code does here. You can always go back to the source code, and it will have that there. But that's what's happening here. We're checking if a key point falls within the attention region, and then I'm going to add in a view for that, right? So if I go here, key point in attention, right? So these are actually all the examples where the actual the key point was within the attention region. And looking back at the code, I think I did that backwards. I think what well no because there's some kind of heat map there. But the point is trying to understand where it is at the if the where it is that the model's doing okay with, right? And so I create a view so I can look at that data. And then what I'm going to do is I'm going to use this information to then tag samples for further fine tuning. And there's two specific tags I want to do. Is a high priority tag and a medium priority tag, right? A high priority is, okay, well, the model predicted incorrectly, and then the attention map that the model produces off target. So it doesn't do well on this task at all. I want it to do well on this task, which is why I have ground truth for it. That gives me a signal that I need to go and either synthetically generate more samples or annotate more or collect more samples for this particular type of task. Medium attention, of course, is if it made the wrong prediction, but part of the attention mask was lit up when the model gave a prediction. So that's the type of tags that we can apply. And so I apply the tag programmatically as I show here. So I'm looking at where it was a false negative and the key point was in the attention map. Here is where there was a false negative and the key point was in the attention map. And then I can create these views here. Sample tags here. And I could see, okay, these are samples that are high priority samples where the model was not looking in the right spot and just the prediction was completely off. So in this case, the task was, in this case, the task was expand the view of this sample, right? So we could highlight here, where's the key point at? I can't see where the key point is lighting up, but Yeah. Okay. So yeah, yeah. So it should have clicked here, right? Expand the modal for this sample. Very bad instruction. And the model's thinking, oh, I should click here, I should click here, I should click here, but not, ground truth is here. So it gives me a sense of, where the model fails and also the sense of how bad of an annotation job I did. Get some basic summary stats. And then, of course, once I identify the samples that are high priority, medium priority, I could then use the synthetic samples plugin to then bootstrap some samples for that use case. And so I could bootstrap it by maybe doing task augmentation, task description augmentation, color augmentation, or resolution change. And so this is how you'd use that sample. Like you could use that plugin. You could use a plugin here. If I do something like synthetic generation, like you could use it right here in the app, right? I could like click on this. I can go here and I could say maybe, I don't know, colorblind inversion and fill out the form. Or I could do rephrase, right? And I could fill out the form. Alternatively, I could just do it via the SDK as well. And then once I've done that, once I've kind of enriched the data set, I've got more coverage in the areas where the model has shown that I need coverage, I can then convert my FiftyOne data set to a torch data set, just defining a get item. So the get item, just to construct the batch, right? I need the file path and I need the annotations. And so that's basically what this is doing. Convert that to a torch data set. And I've got the torch data set. And with that torch data set, you probably need to define some type of a batching or collation function. I have a repo here where I attempted to fine-tune GUI-Actor. I just ran out of computational resources and time because it was taking forever. And I didn't have that big of a GPU, but you could take a look at how you'd continue fine-tuning here. And that's it. That's my presentation. Sorry I went over, guys, by a few minutes. If there's any unanswered questions, I'm going to handle those here.